Hey 12, Mr. Stevens here. Sorry I'm not there with you today, but I just got a quick video here to go over what we need to know for today. We're starting off with our third kind of function in our nonlinear unit today, and that is this thing, sometimes called the reciprocal, sometimes called this word here, which is pronounced hyperbola. You might remember that quadratic functions are sometimes called parabolas. This is like the reciprocal version of that. It's called a hyperbola. This is what it looks like. You'll notice the negative just changes what quadrant the lines are in, but they are always opposite each other like this. We're going to be drawing these basically the same way we drew the other kinds of functions, by drawing a table of values. This kind of function, though, is probably the most difficult one in that we actually need to think a little bit about what values we need to use in our x, because of the way the function works. Depending on what number is here above the x, it will change what numbers we want to put in our x in our table of values. Because if we use these numbers here, -8 to +8, on the example that I'm going to show you, we wouldn't get these bigger numbers that we need, the -4, the -8, that we need to actually make the graph look good. You'll see what I mean in a second. There's a Desmos link here if you need to have a look at graphing some of these things on Desmos. You can always just go to the regular Desmos graphing calculator and type the function in and it will graph it for you. Check out the numbers I've chosen here for this one. Because I now have 2 over x instead of 4 over x, like that example up there said, I've decided to go with some smaller numbers, and I've also included a quarter here. Whoops, I didn't mean to erase that. I've also included a quarter here as one of my x values, instead of stopping at a half like we did up here. Part of the reason I did that is because now that I have 2 over x instead of 4 over x, think about what would happen if I put 8 in. Right, y equals 2 over 8, which equals a quarter. My y values would start to get really small here. And if I put in a half and a quarter, I will start to get some of these bigger numbers that will make it easier for me to plot. If I only stopped at a half, I would end up with not a lot of points that I can graph. You'll see what I mean as we put these in. So this will be a half, negative a half. You can do these in your calculator if you want. This will be -1. This will be -4, and this will be -8. There's no answer here. Feel free to type these into your calculator if you need to. You'll get the answer. And then these are just mirrored. So if we didn't include that quarter, we'd be missing a point that we really need, I think, to graph this, which is this one up here. 1/4 at 8. At a half, we're at 4. At 2, we're at 1. And at 4, we're at a half. So if we only had these 3 points here, it'd be hard to draw the line accurately, I think. I think you really need this one up here to go through. And then we've got the same thing here. At -4, we're at a half. At -2, we're at 1. At -1/2, we're at -4, and at -1/4, we're at -8. Something like that. Arrows on the lines because they extend in both directions. And there we go. Now that we've drawn the graph of 2 over x, we know what's going to happen with the graph of negative 2 over x because it's just going to be the other way around. There'll be a point there at a quarter and 8, there'll be a point there at a half and 4, there'll be a point there at 2 and 1, 4 and a half, so on. And then you can just draw your line and then do the same thing here. And there you go, we've drawn that one too. These are the kinds of questions that we're going to head towards as we get more familiar with these reciprocal functions. Health rating R is calculated by dividing a person's weight in kilograms by the square of the person's height in meters. So R is weight divided by height squared. In part 1, our friend Fred is 72 kilograms and 150 centimeters. Note that this says in meters, so this needs to be 1.5 squared. And we work out his health rating. Using a reciprocal function, he gets a health rating of 32. Over several years, Fred expects to grow 10 centimeters taller. By that time, he wants his health rating to be 25. How much weight should he gain or lose to achieve the same? So he wants his health rating to be 25, and he wants to be 10 centimeters taller. What does his weight need to be? This is just an equation that we know how to solve. We can times by 1.6 squared, times by 1.6 squared, and we'll get Fred's ideal weight in this scenario. 64 kilograms. So he needs to lose 8 kilos in this time. That might not seem like it's a reciprocal function question, but because this is the format of the equation that we're dealt with, that we're given, it is a reciprocal function. We'll see more questions like that in our next lesson that we'll do on Thursday. For now, what you guys can do is jump into the check your understanding questions, and they're mostly going to be that graphing style question. What I would like you to do is draw maybe 1 and 2 by hand, and then at that point I don't mind if you go to Desmos for these next few graphing questions. And then we'll do the models lesson when I'm back with you on Thursday. So you guys can go get into that now. Thank you, and hopefully I'll see you later in the week.